Around 2012, we got started working on this self-driving problem. Over the last 13 years, we picked a problem which is called delivery of goods on the bike lane. And the cost of doing a delivery is in the single-digit dollar. So if the robot costs a lot more than what can be closed in the unit economics equation, it becomes an impractical solution. We had a very hard constraint on the upper limit for the BOM that we had to hit. And that kind of forced us into picking a sensor and a compute which could be built within the 4-digit BOM cost. I think when you're at a big company, you have access to the best possible technology and people's brains. So that is no longer a constraint. Coming to a startup, it's a very resource constrained situation. Less time, less capital, less of everything, but the bar is the same. The breakthroughs that we had in our sensing and foundation model for mobility. Building a sensor that could bridge the gap between a LiDAR and a camera system without compromising the performance was one of the challenges that we had to solve. Architecture of our stack, it has two parallel tracks. One is a very, very intelligent foundation model that plans a path in any complicated scenario, but we have a very, very dumb safety system that has the master type of behavior, which is always guaranteeing collision-free paths.
Today on Eurobridge, we host Mahesh Krishnamurthi. Mahesh is the co-founder of Vayu Robotics, building LiDAR-free foundation model autonomy for real-world delivery robots, which raised a $12.7 million seed round led by Khosla Ventures and was acquired in 2025 by Serve Robotics to accelerate autonomy. Prior to Mahesh's work at Vayu, he worked at Apple as one of the first people on the Autonomous Systems and Lyft on their depth sensing team, and he has incredible knowledge in the intersection of robotics and AI. And today, we're talking to him about his experiences and where robotics are going in the future. Thank you so much for being here on Eurobridge with us today, Mahesh. We really appreciate you taking the time out.
Thank you. Thanks a lot, Tarush. It's been a very, very exciting journey for me to watch your growth from being a toddler to what you're doing now. So very happy to be part of this journey along with you.
Absolutely. So let's kind of get into things. So to start off, could you kind of share what the origin moment of Vayu was, and maybe give a little bit of background on, what is LiDAR and what convinced you to make a LiDAR-free system?
Yeah. So maybe around 2012, we got started working on this self-driving problem. And over the last, 13 years, we've been continuing to work on it. And we have tried to solve a few problems, which were very hard back then, but are much easier now. But one of the key things was the LiDAR is a very, very expensive sensor. And how do you make it scalable was a question mark without losing reliability of the data that you get out of a LiDAR system, right? So that was the big problem that we had in mind. But as we started working on this problem, neural networks grew very rapidly. There were moments when it was hard to even predict a bounding box around a car in a image. Like people would be like, wow, the neural network can do this. But now you can see it, do so many other things. So as it evolved, we saw that a lot more could be done with camera-based sensing without losing fidelity. So that was our main motivation behind, picking a LiDAR-free system. And the advantage you get is you get the performance of a LiDAR, but you can also scale it like a camera. So it kind of bridges the gap between a Waymo and a Tesla. Like Waymos are optimized for safety. They have the best sensors out there in the world, very, very safe, rugged. Teslas, very scalable, but they have some corner cases where they don't have coverage. So we tried to bridge that gap. And the origin story of Vayu is basically like a few people coming together who I have worked with in the past, trying to take a second shot at this problem.
Awesome. I mean, I think obviously you always have to reconcile the unit economics with the technology of the system. So I think what you've accomplished at Vayu is really fantastic.
Correct. Thank you. Thanks a lot. Yeah, I think one of the things that you brought up was the unit economics. Um, as you probably know, we picked a problem which is called, delivery of goods on the bike lane. And the cost of doing a delivery is in the single-digit dollar. So if the robot costs a lot more than what can be closed in the unit economics equation, it becomes an impractical solution. So we had a very hard constraint on the upper limit for the BOM that we had to hit. And that kind of forced us into picking a sensor and a compute which could be built within, like a 4-digit BOM cost.
Absolutely. So you actually mentioned that you started Vayu with, a group of people that you work with, and you started that after, all of your work, very extensive work at Apple and Lyft. So how was the shift from a really big company and those dynamics to scaling a startup, and what did you need to learn versus unlearn?
Okay. Yeah, I think that's a very good question. Um, I think when you're at a big company, you have access to the best possible technology and people's brains, right? And so that is no longer a constraint. So you sometimes get used to it. And coming to a startup, it's a very resource constrained situation, less time, less capital, less of everything, but the bar is the same. So, getting used to becoming more efficient in our thinking, like avoiding experiments which we could perform in our head instead of doing it in the real world, like finding answers through simulation and not spending a lot of time and money on it, was a switch that I had to make mentally. Um, and in terms of the processes, big companies have a lot of processes, and for good reason, because managing large organizations is not straightforward. So we had to come up with a method that would work well for a lean startup that's trying to move and make decisions really fast. So I would say decision making at the speed that we wanted to make them was a big switch that I had to make when I joined the startup and adapted to it. And also, how do we uh, cut down experiments that we can do in our head or in simulations? Yeah, so those were a couple of things. There are probably many more, but these are the two that come to the top of my mind right now. Yeah.
Absolutely. I've always heard this statement that startups versus big companies is like David versus Goliath, where the David is much faster, but
Uh-huh.
also like has a lot less power. Whereas a bigger company, you move slower,
Yeah.
but you can run a lot more.
I agree with you. I agree with you. I think there are pros and cons. That's why I feel like, when you pick a problem, you want to make sure that there is enough technical advantage or a delta in what you're trying to do, so that even if someone tries to run faster or throw money at the problem, it's hard to catch up. So that's something which I believe will keep you protected as a startup or a small company, right? Like if someone could do what you're doing by throwing money or people at the problem, then your defensibility becomes a bit hard. But if you have enough technical delta, then you kind of are in a safer spot. I wouldn't say safe spot, but safer spot.
So, I was very interested to see the launch of Vayu 1, which is obviously 20 mile per hour delivery robot.
Yeah.
So tell us a little bit more about that. What was your biggest challenge in creating technology like that?
Yeah, I think so. The reason, so when we started, I think one of the key theses we had was there are a set of technologies that are available today, and we want to solve full self-driving, but there may be intermediate points along the way where the technology could add value to the world. And what are those things? And delivery of goods at slightly lower speeds, not like really low, but maybe 20 miles per hour is much lower than what the Waymos of the world and Teslas of the world are doing today, right? So we picked a midpoint where there needed to be some technology improvements to achieve that product form factor. And the biggest challenge, I would say, was the breakthroughs that we had in our sensing and foundation
Hmm.
model for mobility. Like building a sensor that could bridge the gap between a LiDAR and a camera system without compromising the performance was
Hmm.
one of the challenges that we had to solve. And on the path planning algorithm, we had to somehow not have access to all the real world data that Waymo and Tesla has, but build a model that is as capable as that at a slightly lower speed without compromising safety. So figuring that part out in simulation using some smart tricks, that would I would say are the two main things that we had to overcome.
Absolutely. Yeah, you brought up a very good point there where sometimes when you don't have that amount of data, building a model is quite challenging.
Correct, correct. Yeah, I agree with you. I think one of the things that we were, I would say, in retrospect, it looks like a decision which was good because, as a startup, we practically cannot collect a lot of real world data, right? Like we have only a few dozen robots compared to thousand robots that maybe Waymo has or Tesla is using way more than thousand to collect the real world data. So we had to pick approaches which relied more on simulation. And it turned out that there are certain hard scenarios that can only be learned in simulation that are very low frequency events in the real world. Right? Like, for example, as a bike lane robot, when you're driving on the bike lane, the car door can suddenly open. And
Hmm.
what you do in that scenario is something that you can learn only when the mistake happens, right?
Hmm.
Uh, that is almost a non-occurrence over the 4 years of my development time at Vayu, right? Like that almost never happened. But we could do a lot of things like that in simulation, and the learning becomes much faster when you encounter these scenes.
Absolutely. And this actually touches on another point, and you've mentioned this. There's a big safety aspect involved with building a robot that's carrying 100 pounds at 20 miles per hour.
Yes.
So, like similar to edge cases like this, how did you handle that?
So, if I can understand the question, your question is, how did you make sure that the robot is safe at 20 miles per hour with 200 pounds? Is the
That's
question, right?
right. Yes,
Yeah.
absolutely.
Okay. So I think so the architecture that we picked is very similar to what animals do. Like animals who are not very, very well evolved. Like, for example, a cat, right?
Hmm.
A cat has whiskers, and that helps put guardrails on the cat so that the cat doesn't get into dangerous situations or go hit itself on some obstacles. So the architecture of our, stack is it has two parallel tracks. One is a very, very intelligent foundation model that plans a path in any complicated scenario. But we have a very, very dumb safety system, which is always guaranteeing collision-free paths. And that is dependent on the coverage of the sensors. And it's always checking if there is any collision going to happen, right? So that has the master type of behavior. So the path that you predict from the simulation based foundation model has to go through this safety checker, and that guarantees the safety at all times. So that is the approach that we took. And this is a very dumb system. It does not have any neural networks. It's very predictable. You can do like math and physics based predictions on this system. So that's how we approached it. Yeah.
I mean, I think that sounds fantastic to kind of have, like, of course, the path needs to be very well defined, but behind that, there also needs to be like a safety system that's very, like, verifiable to make sure that there are no mishaps.
Yes, I agree with you. I agree with you. Yeah, like interpret. And so the other thing that we have developed, which is novel, which is not widely available in the industry, is ability. So these neural networks are black boxes, right?
Hmm.
Nobody seems to understand what is going on inside them. So we built some tools to understand where the model is actually paying attention to. So we can kind of backtrack why the robot made a certain decision by looking at these attention maps, basically looking at, hey, let's say a pedestrian came in, is the robot actually paying attention to the pedestrian or
Hmm.
not? And this helps to debug issues. So that was another tool that we developed, which was very, very powerful. Yeah.
That's really fascinating. I think if you're working with a non-deterministic system, uh, being able to backtrack like that will help you continually improve this technology. And
Yeah.
obviously, I mean, I don't really need to tell you this, but all of this technology is very iterative.
Yeah, I agree with you. I agree with you. Yeah, we went through a lot of iterations of our neural network, and it's still ongoing. And as you go into new areas, I'm pretty sure there will be errors that will happen that we have not thought of before, and it's an iterative process.
Absolutely. So, what I want to kind of ask you about is What are the top three trends in robotics and AI that you want to emphasize that people understand over the next 12 to 18 months? For instance, I mean, there was this recent launch of this home robot, which
Correct.
created a lot of buzz. So, what
Yeah,
are
yeah.
the top three trends in your opinion?
Top three trends. That's a good question. So, of course, you probably know that the humanoids are being, deployed by 1X pretty soon. Figure is into it. Optimus is trying to solve the same problem. Agility is there. So, I think from a technology point of view, ability to have a single brain that works across modalities is something that's developing, and people are working on that problem. Not just have intelligent systems operating on a single robot, but building a brain just like human beings have that can traverse multiple terrains is a trend that is ongoing. And I expect some breakthroughs in that field where you can learn not just from the data from your robot, but any robot's data could be useful to train that brain. So that's one thing that is happening. The second thing that I see happening is a lot of use of simulated and synthetic data sets, because it's a chicken and egg problem where you need data to train the model, but if the model is not ready, you cannot deploy the robot, right? So the solution that people are thinking of is by using simulations for bridging this gap, and the real to sim gap is closing quite a bit. And there are approaches where you capture some real world data and then bring it into the simulator and create a lot of variabilities of that real world scene. So that is evolving quite rapidly. And the third thing I would think is, the hands for the robots are becoming way more capable. Our hands are super capable, right? But the
Hmm,
robot hands are not yet there. So I would expect some breakthroughs or developments at a much rapid speed in that domain. So yeah, those are, I would say, some things that I think we should pay attention to. The other trend that I think is worth watching is, if you really look at the energy spend of compute compute budget that we allocate for neural networks, it's a very inefficient process right now,
hmm.
right? Like, let's say it's a 1 billion parameter model. A lot of these numbers don't contribute to the outcome. And it's just that we don't know which ones these are. And then we distill the model to make it smaller. Given that our brain operates at like 10 watts or 20 watts of power,
Hmm.
there is a huge opportunity for breakthroughs in that area, is my personal opinion. So I think there is a chance that there could be a new form of chip, which is based on photonics or some other new technology that could reduce the energy consumption and the efficiency of operations. Like, one of the things is that there is a lot of convolution involved in neural networks, like matrix multiplication and
That's right.
convolution. Optics provides a very elegant method to do those
Hmm.
convolutions. Like, having a lens is a Fourier transform, and
Interesting.
there are breakthroughs that could happen in that field. So I'm looking forward to that, because I think we spend a lot of money on building data centers, but it feels like a more brute force way of solving the problem instead of improving algorithms and building chips which are more efficient.
That's right. Yeah,
Yeah.
it's very interesting to see how the physical, like the hardware and the software, kind of are approaching each other. Like they're improving, the current. I mean, honestly, this is a little bit of a bold take, but I think the transformer architecture is slowly going to go away. And I think
Hmm.
new architectures, less, I believe transformer is O of n squared, like the time complexity is going to reduce. And
Yeah,
at the same time, the compute is going to get even more optimized. So at some point, these two things are going to converge, which I think is going to be really, really interesting.
that's right. That's right. Yeah.
So, if you were a Gen Z person right now, right? Let's say 14 to 19, you're getting interested in this stuff. What would
Uh-huh.
be your top number one skill to learn to break out into this intersection of AI and robotics? And flip question to that. Let's say you're interviewing somebody. What are
Uh-huh.
the traits you look for?
Yeah, I think that's a very good question. So let me answer the second one first. and maybe I'll go to the first one. I think having a very strong foundation is super valuable. Like when I say foundation, I mean areas like physics, linear algebra, partial differential equations, statistics, probability, and things like that. And geometry and things like that, right? So having good understanding and grasp of the fundamentals at a deep level is super valuable. And having a sense of purpose is also very valuable. There is a lot of work that happens in grade optimization today, but I think that's good. But there is if you want to tap into a more infinite source of energy for your system, if you have a calling or a purpose, then you can probably go deeper or try to solve much harder problems. So I try to look for those two things in people where they have done something which nobody cared about, but only they cared about, and that was their intrinsic motivation. So I would say strong fundamentals and some intrinsic motivation in an area that they are trying to go deep. Having said that, so these are like very fundamental skills for high school students or early college students that I try to look for. And given you are in a high school or in early college, you probably don't have access to very expensive robots, right?
Hmm.
So I would say building some simulation-based solutions is a practical thing you could do, where there are a lot of open source simulators that you can get access to today. Isaac Sim has it, Vex has it, First, I'm sure, also maybe having some form of it. So learning tools to do the robots mission in simulation would be a great skill to have. And given the world is moving towards simulation and synthetic data sets, this is something which does not require a lot of capital. You just need a decent computer and you can run all of these things in the cloud, and a lot of learning can happen in terms of understanding how the algorithms work, how the robots see the world, how the robots manipulate. You can try a new algorithm, see how it works, and things like that. So you can do all the learning before you deploy your model in the real world. And then the whole drama starts, right? That part, I think you probably need access to very expensive robots, or maybe, some level of capital investment is needed to do that. Yeah. So those are some things that I look for.
I think that's a very comprehensive way to examine, where somebody is at with the resources that they have access to. And I
Correct.
also think it's fascinating that I mean, this is like this is the first time in history where you can go onto a simulator and then have an algorithm that is built in the simulator. I mean,
Correct.
like maybe with like very minimal to potentially, if you optimize it super well, no real world data, and then you
Yeah.
can migrate it and maybe it's like 80% effective in the real world.
Yeah.
I think that's
Correct.
fantastic. So,
Yeah.
a lot of opportunities out there.
Yeah. I agree with you. I agree with
Absolutely. Well, thank you so much for your time today. We really, really appreciate you coming on Neural Bridge and giving your perspective to the next generation, and genuinely really appreciate you coming.
Hey, thank you. Thanks a lot, Tarush. It's been great to see your journey from being a toddler to having your own podcast. And I hope someday I can say that, hey, I was on Tarush's podcast very soon. Best of luck for your journey. And I look forward to, being part of it.
Absolutely. Thank
Yeah.
you so much.
See you. Bye.